What's up, Algebra 1 students? Mr. Ford here. My advisor is in the house. We're going to do a quick homework tutorial. This is for 3.3.1, problems 81 through 86. Let's go for it. These first problems are just distributive property problems like the ones we did in class today, so we're just going to carefully multiply. That's going to be negative 20 xy when you're all done, and this is going to be negative 32 y squared. Pay attention to the number of variables you have and the positives and negatives and the numbers there. Question B, when you multiply 9x times negative 4 and 9x times 10y, we're going to have negative 36 for the 9 times 4 and then x. We're also going to have a plus 90xy for the x's and y's that are there. Question C, here's where it's going to get a little complicated. If you're still working on this, you should make a 2 by 3 generic rectangle where it's going to have x squared minus 2 on one side and x squared plus 3x plus 5 on the other side. This is going to give you x to the 4th power in this box, negative 2x squared in this box, 3x to the 3rd in this box, negative 6x in that box, 5x squared in this box, and finally negative 10 in this box. Notice how because of the negative, the top row is all negative and the bottom row is all positive. I also only see one set of like terms that's going to combine together, and it'll be those guys right there. That'll be 3x squared when we add them. So the final answer is going to look something like this. You're going to have x to the 4th plus 3x to the 3rd plus 3x squared minus 6x minus 10. Right there. That's where the I'm highlighting in green the things that are going to combine together for that right there. I'm going to move this mic a little closer to me. Okay, here we go. 383 is going to ask us to actually go backwards this time. They've given us the generic rectangle all filled out, and our job is to figure out what the dimensions are along the side. The good news is that this x squared, there's really only one way to make that happen, is to put an x and an x on either side like that. That kind of unlocks the puzzle for you, because that means that you got to have a 3 down here to make 3x, and a negative 5 up there to make negative 5x, and then it is confirmed that negative 5 times 3 gives you negative 15. So that is your answer there. You're going to have x plus 3 times x minus 5. Please make sure you've written that. There's your product. If you're reading the directions, what we have to do is write the area as a product and as a sum. That would be your product. And as a sum, it's going to be just adding the boxes together. X squared plus, minus 2x minus 15. Like that. That would be the sum. For 384, we're going to do absolute value equations, kind of like we did today in class. My recommendation is for you to take the inside of the absolute value and write it down twice. X minus 3, exactly as it states. Please don't fall into the trap of making that into a plus x. That happens all the time. One of these will equal 5, one of these will equal negative 5, like that. From here, we're going to do the same thing on both sides of both equations and just add 3 to everything. This will cancel out the 3 in both equations and leave you with x equals 8 over here and x equals negative 2 over there. Those are your two answers. Question B is going to be kind of the same, although in this question, since that 5 is hanging out outside the absolute value, we should go ahead and divide it away right now and cancel it out. That'll leave us with absolute value of x equals 7, and now we can split it up into two equations, x equals 7 and x equals negative 7. Those are the two that we're looking for there. Question C, we again have x plus 1 equals 2. What you want to remember here is that you want to split it up into x plus 1 equals and x plus 1 equals. Keep that inside part exactly the same. One of these will equal 2. One of these will equal negative 2. That's the pattern. So pay attention to the pattern and reward yourself with the pattern. Same pattern up there. Inside part stays the same. The number is going to be positive and negative. From here, we're going to solve both these problems at the same time by subtracting 1 from everything. Over here, we're going to get x equals 1 for the first answer and x equals negative 3 for the second answer. Make sure you show all the work also. And finally, question D, which is a question that I told you in class is going to happen. This has no solution. And the reason why is because I've got an absolute value here that is supposedly equal to a negative number. That will never happen. Absolute values are always positive. Next, we have a set of diamond problems to do here. Remember, the key is up there. We're going to multiply to get the top number and add to get the bottom number. Now in this first problem, we're given one of the two numbers and we're given the multiplication. We know that -1 times some number is -4. That number has got to be 4 right there. And then if you add them together, it's 3. Here we're given the two numbers, so if we multiply them together, you get a positive 16. If you add them, you get a -8. Not much more to say about that. Here we have one of the numbers and its sum, so -3 plus the mystery number is going to give you 8, and so you're going to require the number 11 here. -3 plus 11, and then if you multiply those together, it's -33. And then finally, you've got the classic diamond problem where they've given you the multiplication problem and the addition problem, and you got to figure out what the two numbers are. The nice thing is that 7 only has one set of numbers, which is 1 and 7. The only question is which one's going to be negative and which one's positive. If you want to keep that to be positive 6, it's got to be -1. That way you add them together and get positive 6. And finally, we got just some simple function notation problems here. Plug in some numbers and get an answer. This would be 7 plus the absolute value of -5, which is 7 plus 5, which is 12. Please show as much work as possible. G of 4 would be 4 to the third power minus 5. Use a calculator for this one. 4 to the third power is 64, and 64 minus 5 is 59. Question C, f of 0 is going to be 7 plus the absolute value of 0, which is just 7. Question D is f of 2, which is 7 plus the absolute value of 2, which is 7 plus 2, which is 9. G of -2 is going to be -2 to the third power, I forgot the function, minus 5. -2 to the third power, be careful on this one, that's going to be -8. That's -2 times -2 times -2, which is -8, minus 5, which is going to be -13. And then finally, G of 0, which is 0 to the third power minus 5, which is just going to be -5, and there's nothing more to say about that. I hope you enjoyed this homework tutorial. Pretty quick one, pretty easy to do. I'll see you in the next video. Don't forget, you're awesome.